Conservation of Mass by Rhoda Mowbray, Jessica Hall, Isaac Hess, and Emma Gifford.
Our question was, can the conservation of mass hold true to both physical and chemical changes?
In our sugar and water experiment, our test of physical changes, it had us dissolving sugar from its crystalline form into water, a more free-flowing state.
Some physical observations in the sugar and water experiment included an increase of the water's viscosity and a lowering of the clarity of the mixture.
The magnesium and hydrochloric acid experiment had us insert a ribbon of magnesium into a tube of hydrochloric acid. We noticed there was bubbling, a lot of heat released, and vapor being produced.
This was a chemical change, and we set a small stick of wood alight and dropped it into the mixture, which resulted in a burnt smell, a pop noise, and more heat. The popping noise proved that a hydrogen gas was created.
Our claim is the law of conservation of mass does hold true in both physical and chemical interactions.
In both chemical and physical experiments, we proved that the law of conservation of mass held true by recording how much mass our reactants and products had throughout our experiment.
At the beginning of our experiment, we calculated that our magnesium weighed 0.11 grams and our hydrochloric acid weighed 8.67 grams.
By the end of our experiment, we found out that we had 8.5 grams of magnesium chloride. We also proved that there is hydrogen present by lighting a match and watching it extinguish in the resulting product of our experiment.
At the beginning of our sugar and water experiment, we calculated that our sugar weighed exactly 5 grams and our water weighed 47.52 grams. This would mean that our finished product should have weighed 52.52 grams.
But through human error to be explained later, our product of the sugar and water experiment weighed above the projected amount, with it having the mass of 54.8 grams.
Our chemical or magnesium hydrochloric acid experiment resulted in the calculatable mass of the resultants of the reaction having a cumulative mass of 8.5 grams, meaning realistically that the unmeasurable hydrogen had to have had a mass of 0.28 grams to make the chemical equation equal.
In the physical experiment, we got a resulting mass greater than that of our reactants, despite us having less sugar in the cup at the end of our experiment due to human error. But besides that one problem, all of our measurements were done correctly, so the real culprit of our mismatching masses in this experiment was our faulty scale.
A systematic error that we came across while conducting our experiment was that our scale did not work properly as intended. It did not zero out when we wanted.
Another error that occurred was a human error during the sugar and water experiment. While stirring the sugar, we became too vigorous, and some of the mixture launched into the atmosphere and was lost to the space-time continuum.
This is a very tragic day, yet somehow the scale decided that the mixture had gained mass despite there being less sugar in the red Solo cup.
We will mourn.
This is the end. We will now die and launch our corpses into the funkiness of the space-time continuum, and will be forever lost like our sugar.